0, you should never call it directly yourself. You get it called by having the reference count go to 0. You have the reference count go to 0 by correctly balancing your retain or alloc inits with releases. So here's what the call looks like under the hood, but don't do that yourself. So if you have an object that has an object with an object, and that has an instance variable to an object, and you've retained those objects all the way down through the hierarchy, somehow you have to make sure to clean up after yourself. If you need to clean up those instance variables, what can we do? It's a lot like C++. Override the deallocate. So deallocate is called when your reference count hits 0. It's called before the memory is released. So if dealloc gets called, then you can call release on any objects that your object contains as instance variables, which can call release, which can call release, which can call release. Everything gets nicely cleaned up as it rolls back up. When it hits 0, it gets called. So most of the time, unless you have a very trivial class, a lot of times you'll see that you'll be overriding dealloc because you need to release all of the attached all of the attached objects in your instance variables. So here's the pattern: release your objects first, then call your superclasses dealloc. This is okay because it's within the dealloc method. You're calling your superclass to make sure that your superclass cleans up. That way, if one of these releases calls a release on something inside of something, everything gets cleaned up and unwound automatically and cleanly. So, back to properties. How does this all retain the properties? So, remember there's the properties specify a getter and a setter for your instance variables. You can specify what type of setter your setter method is. So typically it's assign. That's by default. That means when you use the dot notation, all it does is assign the value of that object or that value of that primitive to that instance variable. All right? So if you have pointers, it just assigns the value of the pointer. It doesn't assign a copy of any of the contents of the pointer, just makes another reference. There's also retain. Retain does pretty much what you might think it's going to do by now. When you make a reference to an object, it not only copies the value of that object, but it also increases the retain count by 1. So this is a really handy way to do all-in-one, to create an object, and once you use this setter, like on a string, you can automatically have retain called. There's also copy, which makes a copy of the object. This actually calls the object's copy method. NSObject doesn't have a copy method for good reason. And the reason is that typically in other languages, these copies are shallow copies. Shallow copies means copy only the values that are there, including pointer values. So all the pointers are still pointing to the same memory. You haven't made complete copies of instances. You've made copies of primitive values, and you made copies of the pointers that all point to the same memory. You release one, now you got a dangling pointer in the other. So you have to implement a copy, you have to override and implement a copy method. Yes?
So all of these, so within the class itself, right, these are properties for your properties, right? So you have to access it like self dot. If you don't access it as a property, none of this happens, right? Is that correct?
So like if you were doing like a self, and those are getters though.
Yeah, well, let's say you have an instance variable that's an object, and it's date or something,
Yeah.
and it's set as retained.
Okay.
And then let's say you're within the class and you want to set that date object.
Yeah.
If you don't say self.date, you don't refer to it as a property, well, it's still
No, I see. If you're directly manipulating the instance variable and not using the setters and getters that are written by the properties, you won't get these behaviors.
Okay.
So, but you can get these behaviors either by using the dot notation or by calling the methods that the compiler will write for you.
Okay.
So you can also do it with the angle bracket, set value, set property colon property value, and then that will get whatever behavior you've set on that setter.
So using a normal assignment, let's say you have an auto-release date, and you're just doing an assignment like equals, and if you say self.date equals some auto-release object, it will retain. But if you just do date equals.
Correct. Yeah. If you just assign to the instance variable, it's just using a normal C assignment.
Right. Just assigning the value, and then it's going to get auto-released out from underneath it.
Again, the thing to keep in mind there is that when you use the dot notation, the compiler will actually expand those into the corresponding method call.
Yeah.
So, here's an example of a sign. This may clear up some of this a little bit for you. So here's the property. Here's what the property declaration looks like. Assign, type, and then the variable name. Using the dot notation, new value gets converted under the hood to object set property name to the new value. Just a set. So retain, property retain, object, and then the name of the property. Using it, accessing with object dot property name is new value, gets converted under the hood to object set property name, take that value, retain it, and then assign it.
There's a bit more cleverness we're hiding from you, but that's the general idea.
Yeah. And then under the hood for copy, same idea. Property copy, type, variable name, object.property name equals new variable. Under the hood gets turned into object set property name, calls the new value copy, which returns you back a copy of new value, which is an NS object, and then sets the property. Also does some funky things under the hood, but remember, copy is one of our things that we need to pair with release, right? Alec, copy, and retain. So, since they both increase, retain and copy both increase the counts, this is what I was just saying. You need to call release on the object if it's going to be they need to call release on the object if they get reassigned. So actually, let me show you an example of that, which should make this clear. So we have two objects here that we're creating, some object and some other object. We make a variable that has the copy property. We do self.some variable equals some object, and it makes a copy of some object and sets some variable to it. If we do an immediate set right after that, some variable needs to get rid of the copy of some object. The copy setter does that under the hood for you. So it'll call release on the copy of some object. However, if you set it down here, the last time you've set it, it doesn't know that it needs to release it out from underneath you. It doesn't want to release it out from underneath you. So unless you have multiple sets, even if you have multiple sets in a row on a copyable property, you still need to release this last copy. Does that make sense? So you need to make sure that you balance retain and copies with releases. If you just keep reassigning, keep setting the same ones in a row, using the same variable in a row, it's going to call release on the old values under the hood. You need to release it, is basically what that says. You need to release the last value that was copied. So if you have properties that use retain and copy, you still need to make sure that what they're pointing to gets released and gets released correctly, which means if they've got objects within objects within objects, they need to be released also. The way you do that is overriding the dealloc method, and you're going to need to do that for your properties that are retained properties or copy properties. That's important.
Otherwise, you're going to leak the last one of the set.
Right. So if you have a property that retains something automatically when it's set, and you set it, then you need to make sure that that property has a dealloc that calls release on that object, if it's responsible for it. And when is it responsible for it? 3 cases. Alloc, retain, copy. That's it. So yes, long.
Yeah, sorry not been long today, but it's an important concept.
Yes, this is something this is one of the reasons that ARC has been heavily worked on, because this is a tough concept for people to get right. Getting it working is usually not too bad. Getting it right is a lot tougher. So practicing with it now will make you understand memory management to a much greater degree. Then when you use garbage collection or automatic reference counting, which we'll talk about next time, then it'll make a lot more sense to you what's going on in the hood, and you'll feel a lot more in control of what's going on. I hate it when using like a JVM that all of a sudden my program hangs for 20 seconds because it's garbage collecting and I have no idea why. It drives me crazy. And I got to run NetBeans and run the profiler and figure out exactly what's going on. I'd much rather know what's going on under the hood. This is what's going on under the hood. And you're going to get practice with it this time, this lab, and you get practice with it next time too. And you'll see that the auto release pool is not quite as magical as it seems. All right.
Okay, lab's up. So go ahead and get started. It's a fun one.